Section 3.1, identify lines and angle pairs, so pairs of lines and angles. And we are going to look at parallel and perpendicular lines, and we are also going to look at angles, the names of angles that are formed when we take and cut some parallel lines by a transversal, or lines in general by a transversal. So here's where we begin. Parallel lines you are probably pretty familiar with. They do not intersect and they are in the same plane. So you have to make sure you understand, then remember that these are in the same plane. So we could say that these two lines are parallel because of the markings I just made, which is a little arrow. And so we could say that line W is parallel to line X. And this right here, that symbol right there, that means, that's the symbol we use, that means that it's parallel to. Parallel planes are two planes that don't intersect. So from this drawing or diagram, we could say that plane P is parallel to plane Q. And again, these never intersect because they are the same distance apart. If they weren't, then either the lines would intersect or the planes would intersect. The next pair of lines we're going to look at are perpendicular lines. So perpendicular lines are two lines that intersect to form a right angle. So we can see this marking right here is a right angle symbol. So we can say that line Y is perpendicular to line Z. And again, this symbol right there, that means, that's the symbol we use, is perpendicular to. Skew lines, on the other hand, are two lines that do not intersect and are not in the same plane. So our skew lines here could be line X and line Y would be skew lines because even though they're not going to intersect, they are in different planes and they are not necessarily the same distance apart. So we can say that line X and line Y are called skew. Clean that up a little bit. Okay, so let's try to use that information to pick out some information and figure out from this diagram some of these things we just talked about. So, which line plane contain point T? Okay, so all of them have to contain point T and would be a line parallel to DE. So it has to contain this point T right here, but also has to be parallel to DE. So here's DE right here. So what line would contain it and also be parallel to it? And that would be CT. So we would write line CT with the line symbol over the top. So now we want a line that is perpendicular to CD. So perpendicular to CD right here, but also contains point T. And that is actually the same line. That is going to be line CT again. So we had these were parallel, and now we have this is the one that is also perpendicular to that line. So now let's talk about a line skew to CD. So a line that would be skew to CD. So again, here is our CD right here. And a line that's skewed to it that also contains point T would be that back corner or edge behind. So that would be TG, line TG right there. And then finally, we want a plane that's parallel to DEH. So here is plane DEH, and a plane that would be parallel and also contain T would be plane TCA, or we could call it plane TGC, something like that, but this plane over there. So that's using the information about parallel, perpendicular, skew. Let's try another example here. Why don't you read through these questions, and I'd like you to try to see if you can pick them out. The key here is it says think of each segment in the figure as part of a line and which lines or planes in the figure appear to fit the description. Because if we're actually going to verify, we would have to have some markings. So read, for example, A, lines parallel to AF and containing point E. So here is we want a line that's parallel to AF and contains point E. So it looks like the line that would be parallel to it and contain it would be EJ. So EJ. We could list all the lines that appear parallel to AF, okay? But only one really contains point AE, or contains point E, and that would be EJ. So what line is skewed to AF and contains point E? So again, it can't be in the same plane, but it has to contain point E, so it would be ED. Again, there may be other skew lines, like we could say not only that one, but other skew lines would be like JI, or what other one can I name? BC. Okay, so there are other ones, just like I could have named other lines that were parallel in the example above, like another line that appears parallel would be like ID. But these are the actual ones that only contain point E. So these are the actual answers to the questions, but they're just asking you to maybe try to describe some other possible lines that are parallel or skew. So let's go on to C, lines perpendicular to AF that contain E. So what looks like it would be perpendicular to it, and that would be this line right here. It appears that it is AE. Again, we don't have the right angle marking to verify, but this would be AE. And that is our answer. So again, what other lines could be perpendicular to AF? Well, it looks like you could have AB might also be perpendicular to it as well. And the last question asks, which plane appears to be parallel to plane FGH? So let's look at plane FGH. And contains point E. And that would be plane EBC. So this plane is what we're looking at, and this plane looks like it would be parallel. So that we could say that it is plane A, B, C. Right there. All right. So now let's talk about transversals. What is a transversal? This is probably something that maybe you have not encountered before, but a transversal right here is any line, ray, or segment that intersects two or more coplanar lines, rays, or segments at different points. So here you have a line, and here you have a line right here, and your transversal is right here. So this is your transversal. And it's intersecting at these 2 points, and they are in the same plane right there. In this diagram, this is a transversal. Again, it's intersecting at a minimum of 2 different points. It's actually intersecting these 2 lines, and it's intersecting these 2 lines. And that is your transversal. Well, we actually have names for the angles that are formed. And by that transversal intersecting. So again, here is my transversal. It's intersecting these 2 lines right here at these 2 points. And you have 8 different angles that are formed, and I have numbered them. So we have different names. The first one we're going to look at is called alternate interior angles. Alternate, what does that mean? It kind of means going back and forth. We're alternating back and forth. Well, so what we're doing is we're alternating back and forth across the transversal, and it is on the interior of the parallel lines. So if you look at angles 3 and angle 6, they alternate across the transversal right here. They're alternating across the transversal, and they are on the inside of the parallel lines. So we call them alternate interior. So inside or interior, we could call this. And so it kind of describes itself. Alternate interior angles. Is there another pair? Yes. And angle 4 and angle 5 are alternate interior angles. So alternate exterior angles alternate but are on the exterior. So they're on the exterior or the outsides of those lines. And they're not parallel lines. I think I mentioned that earlier. They're just lines. We're going to talk about parallel lines and what that does to these angles as well in the next lesson. But now they lie on the outside, but they still alternate across the transversal. So if you look at angle 2 and angle 7, they're alternating across the transversal right here. They're going across it, but they're on the exterior outside. So we have angle 2 and angle 7, and we also have another pair, angle 1 and angle 4. Now those 2 kind of describe itself, okay? The next 2 we're going to look at, one does and one really doesn't. So let's look at the one that does describe itself first, okay? I'm going to jump down here to consecutive interior. Consecutive means next, right after another, okay? And they're on the interior, again, of these lines that the transversal is intersecting. So again, here's our transversal, and it's intersecting those lines. So now, again, we still want the interior or inside of the lines, but now they're consecutive interior. They're not alternating across, they are consecutive. They're next to each other, like this. So that is angle 4 and angle 6. And again, we have another pair, angle 3 and angle 5. So the last pair we're going to look at here are called corresponding. Corresponding angles are like corresponding position. And what that kind of means, what I like to think about it, is the same side of the transversal and same side of the line. So another way to look at it, you could also, it's like in the same quadrant. If you think about this right here as a quadrant on a graph, like an XY graph, and this as a quadrant of the graph, it's like in the same quadrant. So I'm looking for it to be on the same, like in the same quadrant. So that would be like angle 2 right here and angle 6. They're both in quadrant 1 on a grid. So angle 2 and angle 6. Another pair that are like in the same quadrant, or again, it's on the same side of the transversal. So if we look at angle 1 and angle 6, they're on the same side of the transversal, and they're both above the line, same side of the line, like above. So angle 1 and angle 5. There's actually 2 more pairs of this. If you look at angle 3 right here and angle 7, they're both below the lines and on the left side of the transversal. And the last pair would be angle 4 and angle 8. So these have names, okay? And you're going to need to know the difference between those names. And we are going to actually use these names quite often over the entire course. So let's see if we can pick out, identify all the pairs of angles of the given type. So let's do the corresponding first, because that's the one we just talked about. So a pair of corresponding would be 6 and 2. So again, if you look at the lines here, the picture is drawn a different direction maybe, okay, but that's okay. Here's your transversal. And so now if you look at these angles, they're both on the left sides of the line and above the transversal. So angle 2 and angle 6. Another pair would be on the left side of those lines and above the transversal. So we could say angle 1 and angle 5. We also have angle 3 and angle 7 and angle 4 and angle 8. So again, you can think about it as the position or kind of the quadrant idea. So now let's look at alternate interior angles. Alternating across the transversal and on the interior of those lines. So this is the interior of the lines. The transversal is intersecting. So alternating across the transversal would be angle 2 and angle 7, or angle 4 and angle 5. Alternate exterior. Now this is the exterior of those lines. And so it's alternating across the transversal, but it's on the exterior. So if we look at angle 8 right here and we look at angle 1 right here, they're alternating across the transversal and they're on the exterior. So angle 1 and angle 8, but we also have the other pair, angle 3 and angle 6. Consecutive interior angles are on the interior again, but they're not alternating, they're consecutive, so 4 and 7. So angle 4 and angle 7, and we also have the other pair, angle 2 and angle 5. Okay, let's look at this next example, example 3. Identify the pair of the numbered angles. So what type of angle is that? Well, it is, again, these are, if we look at the lines, again, I'll highlight them, okay, and the transversal, they're not alternating across the transversal, okay, here's the transversal, I'll draw that in again. Here's your transversal. They're not alternating, so they're not going to alternate interior or exterior, okay? They are not both on the interior, so they're not consecutive interior, so what they are is they are in the same position. So these are corresponding angles. Okay, let's look at the next one. Again, here are your lines and your transversal. Now when you look at this, these are alternating across the transversal, but they are on the exterior. So these are alternate exterior angles. And the next one here, again, sometimes it's helpful to use your highlighter and highlight the lines, and then you can make out the transversal a little bit easier. So now we can look at, these are also alternating across the transversal, but they're on the interior. So these are alternate interior angles. So that gives you a little practice and some review of some parallel lines, the things that you have.